Hi, everyone. Let's take a look at number 13 on page 387. Part A, given the vectors P, which equals to -1, 3, and 0, and vector Q, which equals to 1, -5, and 2, determine the components of a vector perpendicular to each of these vectors. Step 1, think about the cross product, P cross Q. This means you're looking at -1, 3, and 0 crossing 1, 5, or 1, -5, and 2. And again, the way you do this is you can copy the vectors such that the first vector is at the top, second vector at the bottom, and in the x component, you take 3 times 2 minus 5 times or -5 times 0. Again, 3 times 2 minus -5 times 0, which is going to be 6 minus 0, so that's 6. In the last column, you can take -1 times -5 minus 1 times 3. Again, -1 times -5 minus 1 times 3. That's going to be 5 minus 3, which is going to be 2. If you look at the middle column, you do the exact opposite. So you're going to take 1 times 0 minus 2 times -1. Again, 1 times 0 minus 2 times -1. That's going to be 0 plus 2, which is going to be 2. Now, the truth is, this is not the only answer. 6, 2, 2 is one possible answer. What's another possible answer? It could be any scalar multiple of 6, 2, 2. So if you divided this by 2, and you're thinking, what about 3, 1, 1? Well, that works too. Now, the key is you want to double check. So to double check, what you have to do is you look at the vector 3, 1, 1. Let me switch colors for you. Take the answer, dot it to one of the vectors. You should ideally double check for both of them, of course. If I just double check with the first vector, look what happens. 3 times -1 is -3, plus 1 times 3 is going to be 3, plus 1 times 0 is going to be 0, and the dot product is going to be 0. Because the dot product is 0, therefore they're perpendicular. So you can do the same thing by double checking with 1, -5, and 2. So again, there are infinite many answers in terms of a vector perpendicular to each of these vectors, and I've demonstrated 2 of them. Let's keep going. On the next slide deck, I'm going to stick this question again. I would like you to try part B. Press pause, try it. When you're done and you press play again, I'll be here. Welcome back. Again, step number 1, self-belief. You got this. You can do it. Step 2. If you think about a vector that's going to be perpendicular to both vector m and vector n, you would take 1, 3, -4, cross this with -1, -2, and 3. Again, copy 1, 3, -4 at the top, -1, -2, 3 at the bottom. In the first component, take 3 times 3 minus -2 times -4. Again, 3 times 3 minus -2 times -4. And the last component, you can take 1 times -2 minus 3 times -1. Again, 1 times -2 minus 3 times -1. In the middle column is going to be the opposite sequence. You're going to take -1 times -4 minus 1 times 3. So -1 times -4 minus 1 times 3. Here's the answer. 9 plus 8 is going to be 17. 4 minus 3 is going to be 1. And -2 plus 3 is going to be 1. Now, as I'm double checking my work, I realize it is not 17. That was my mistake. Let's try again. 9 minus 8, that's 1. And again, is this the only answer? No, because it could be any scalar multiple of 1, 1, 1. So let's pretend you decided to multiply this by 2. What about 2, 2, 2? Let's double check. If you take the dot product, again, you have to take the dot product choice, but I'm just going to show you the first part. Let's say I take the dot product of the answer 222 with -1, -2, and 3. Look what happens. 2 times -1 is -2, plus 2 times -2 is -4, plus 2 times 3 is going to be 6, and that's going to be 0. So this means the answer is perpendicular to vector n. And I trust that when you double check it with vector m, it's going to be the same thing. So again, infinite many answers, any scalar multiple of 111 is going to work. If you find this video meaningful, it's adding value to your math life, please comment, like, share, and subscribe. I hope this makes sense.